Okay, so with my high-tech setup, today we are going to find out the scalar projection of 4a plus 3b onto b if the magnitude of a is 2 and the magnitude of b is 4 and the angle between a and b is 120 degrees. Alright, so first we're going to start off with our initial formula, which is x, dot y equals cosine theta x magnitude of x times the magnitude of y. Alright, so that is if we have a triangle, this x and this y, then we are going to take the cosine of x onto y, so like this guy here, times y, and that'll give us some value like this. But of course it is a scalar, not a vector, so because it could also be over here, we don't really know. Anyway, so we're going to do the scalar projection. So that means if we have x and y, then we're going to take this guy, a nice 90-degree angle down here, and we're going to try to find out what this value here is. So this is the scalar projection, just as if a light was shining down here. There's a little sun. And your shadow, straight down. Okay. So we have theta between them. So cosine theta equals adjacent over hypotenuse. So in this case, our adjacent is this bold guy, which we're trying to find here. We're just going to call it our scalar, because it's our scalar projection, divided by hypotenuse, which is x. So, but we just want to find the scalar. So scalar is going to equal cosine theta times x. Alright, so now we want to make this formula look like this. So all we're going to do is move over the y. So to get rid of multiplication, you always divide. So it leaves us with x dot y divided by the magnitude of y equals cosine theta magnitude of x. Alright, and this is our scalar projection. Alright, but in this example, we have 4a plus 3b onto b instead of x onto y. So, since we don't have the angle between 4a plus 3b and b, then we can't really use this side of the equation, so we're going to have to use this side instead. So our x is what's being projected, so that's going to be our 4a plus 3b dot y, which is what's being projected onto, so in this case it's b, divided by, that's supposed to be the magnitude of b equals, and cosine theta x, as we know, here it is going to equal our scalar projection. Okay? So, what we can do here, which is nice with dot product, is it works just like multiplication. We can just use distributive property. So, 4a dot b plus 3b dot b. And going back to the question, we know that the magnitude of b is 4. So, divided by 4. Alright, I'm running out of room, so we're going to have to go up here. So 4a dot b, you can imagine this as 4 little a's times, or dot, by 1b. Now we know this theta in here because it said the angle between a and b is 120 degrees. So we can plug that in, so cos 120 degrees. Now we're following this formula here, right? Because we want to do x dot y, except it's 4a dot b. So times the magnitude of a, so that's 2, but there's 4 of them this time, so that's actually times 8. Times, so what's next? The magnitude of y, in this case b. So times 4. Plus, now this time we have 3b's times, or dot 1b. So the angle between these two vectors is going to be 0. because they're the same vector, basically. Cos 0 degrees. And then times the magnitude of x, which in this case is b. So 4 times 3, because there's 3 of them. It's going to be times 12. And then times the magnitude of b, which is 4. All divided by 4. Okay, so now I already punched this into my calculator, and this is negative 16 plus 48 over 4. And now it just becomes simple math, and your equal signs should be lined up, but I don't have really enough room here for that. So 48 minus 16, 4 take away 10 is 38. 38, that should be 32 divided by 4. And 32 divided by 2 is 16 divided by 2, again, is 8. So therefore, our scalar projection, oh, I'm going to drop my paper, whatever, is 8. So that means this value over here is 8. So to recap, that's because we have 4a plus 3b over b. So we took our new formula that we found for scalar projection, which is x dot y divided by the magnitude of y is equal to scalar projection. Okay, so we've plugged in our x, we plugged in our y's, our magnitude of y, and then we did distributive formula, and then from there you just solved it all out. And that's it. All right, so good luck with that.